Hello everyone, welcome to next video tutorial on uh, doubly linked list. In the previous video, I have explained what is doubly linked list and how we perform the different operations on it. In today's class, I am going to cover circular doubly linked list, then circular doubly linked list with header node. Okay. So what is circular doubly linked list? Difference between doubly linked list and circular doubly linked list is that in only doubly linked list, the first node left link contain the null value. Similarly, the last node right link contain uh, the null value. But here in the circular doubly linked list, uh, first node left link contain the address of last node, and the last node right link contain the address of first node. Then only it becomes a circular. Okay. Then first operation is inserting an element from the front end. Okay. First is create a node, get node function, assign a name to it. So temp node is created and you want to insert the item into it. Temp pointer info equal to item. The 50 will be inserted. Then earlier the left link and right link are contain the null value, but now it is a circular linked list, so it will point it to the same node. Temp pointer left link, temp pointer right link, they are uh, given to the same node like temp here. Then insert into empty list. If first equal to null, the list is empty. Whatever the new node created, that is the only node in the given linked list. That time you have to return temp here. Then I'm going to insert the element at the front end. Uh, Front end, that is temp will be added at the front one. What we have to do for that? First, earlier the address available from uh, first pointer left link contain the address of last node, then last pointer right link and address of the first node, but temp become the first node. Now we have to replace those two links from earlier. These two links will be gets changed to where? Changed to the temp. Okay. Now temp pointer left link contain the address of last node, last pointer right link contain the address of temp node now. And again we have to provide the connection between this temp node and the first node. Okay. So in order to make changes of this these two address, we required the address of last node. Earlier what we have to do, in order to get the last node, we have to start from the first node. We have to visit until the last node right link matches with the null character. But because of circular linked list, we directly get the last node. How to get it? Last equal to first pointer left link, so this will give the last node. Then we can add this temp node as the first node. Now how to do this? Temp pointer right link is equal to first. Temp pointer right link equal to first. Similarly, first pointer left link equal to temp. First pointer left link equal to temp. So this one is connected to the first node. Then we have to replace these two from earlier from last node to first node. Now we have to change from last node to the temp node. So how to do this? Last pointer r link equal to temp. Then temp pointer left link equal to last. That we have done here. Then return temp. The temp become the first node. You have to return the first node always. So return temp now. Then write all these steps inside the function. Okay. Then second one, inserting the element from the rear end. Step 1 and step 2 remain same. In the step 3, earlier I am adding it to the beginning of the list, but now I am adding at the right end of the list, or you can say the rear end. Okay. So this temp node will be added now. In order to add this temp node, where we are going to add? We are going to add at the last node of an existing linked list. So last node is here. This is the last node. With this list I'm going to add the new element. Okay. So first step, obtain the address of last node. How to get it? Last node equal to first pointer left link. First pointer left link give the address of last node. Then attach this last node to the temp. So how to get it? Last pointer right link connected to where? Temp. Last pointer right link equal to temp. Similarly, temp pointer left link connected to the last. Temp pointer left link equal to last. Okay. Now we need to change these two uh, address from earlier, from this node to the first node is there. Now now this uh, temp become the last node, so we have to make changes over there. So what to do, temp pointer right link is connected to the first, then first pointer left link is changes to uh, temp. That we have to do, like first pointer left link equal to temp, temp pointer right link equal to first, then return temp. Temp becomes the uh, now you have to return not first, you have to return uh, instead of return temp you have to write return first, because the first node is in the same place. Now write all the function steps, these steps inside the function. Okay, then next is delete an element from the front end. Okay, so first check for the empty list. If first equal to null, okay, that time you can say the list is empty. Similarly, delete if only one node is there. How to check it? If first pointer r link equal to first, it is connected to it is pointed to the same node. That time you can say that it contains only one node. Then printf item deleted equal to percentage d first pointer info. This 50 will be deleted. Then free first return null. After deleting this, null will be left that you have to return. Then if it contains more than one node, means in the given list it contains four node. What you have to delete? You have to delete the first node. Okay. Uh, so if I delete this first node, this second node becomes the first node. Okay, and you have to change this link also. Earlier first pointer last link contain the address of last node. Similarly last pointer right link contain the address of first, but now after deleting this, last pointer right link contain the address of second, then second pointer left link contain the address of the last. That changes you have to make. Okay, so how to make it? First obtain the address of second and last node. Okay, second equal to first pointer right link. First pointer right link will give second. Similarly, last equal to first pointer left link. We got both second and last value. Then make second as the first one. Then second pointer left link, as I told, second pointer left link is pointed to where? The last. Then last pointer right link, it is pointed to second. After deleting this, we have to change these two address to second. Okay. Then step 5, delete the first node. Printf item deleted equal to percentage d first pointer info free first. Okay, this first node will be freed. Then return the already return the first node, which is the first node now. First node is second. Okay, then write this function, call this function. Inside that, write all the 6 steps. Then last function is uh, uh, delete an element from the rear end. So you have to delete this last node. Okay, so these two steps remain same. Obtain the address of last but one node. Why we require this previous node? Because after deleting this becomes the last node. So we have to change these two address to these two link to last node now, previous one, because this becomes the last node. We have to delete this. Then what is change to be done? After deleting this, earlier the last pointer right link contains the address of first, then first pointer left link contains the address of last. But now after deleting this, previous pointer right link contains the address of first, then first pointer left link contains the address of previous. Then only this becomes complete. So first obtain the address of last and last but one node. Last equal to, directly we get it, first pointer left link. Okay, first pointer left link will give the address of last link. Then previous is previous, this one is last, previous last pointer left link will give the previous. Okay, last pointer left link will give previous. Then we have to delete this, make this as the last node. Okay, previous pointer right link contain the address of first, previous pointer right link contain the address of first. Similarly, first pointer left link contain the address of previous. That you have to write. Then delete the element and free last. Then first element remains the same, return first. Write all the steps inside the function. Okay, then last one, display circular doubly linked list. Like current equal to first, we have to visit each of the node and get the uh, display the each of the information directly here. Current equal to first, last equal to first pointer left link. We get the last node directly. Then until the current reaches to the last, we have to display all the information. Okay. Then same time you can display the number of nodes in the given list by using count value. Okay. This one is regarding circular doubly linked list. In the next video, I will explain circular doubly linked list with header node. Thank you.